da 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 da. Okay, we are now ready to do T confidence intervals for mu. Now here's our scenario. We've surveyed a whole bunch of people. We're going to talk about how long can they hold their breath. I know you're curious. You can time yourself with me. Can you hold your breath as long as me? I'm going to draw the picture while I hold it. Oh, we got one little problem right here. Notice I've got sigma over the square root of n, but is it sigma that I've got right here? Notice the standard deviation comes out of the number of people that we've surveyed. So this isn't sigma, this is S. Let me change my picture. Keep holding your breath. That means this technically isn't actually a Z curve, this is a T curve. With how many degrees of freedom? It's n minus 1, 64 people, so we've got 63 as our degrees of freedom. Here's the way that we used to do confidence intervals. I'll write it while still holding my breath. I'm sure you're competing yourself against me. There's the equation we used to have when we were doing the Z-scores. How does it change for T? You can probably guess. It's more like this. So here's your equation for how that T-score works. Notice the only difference here is we've got T and we've got S over the square root of n. So plugging in the stuff we already know based on the problem, we can do this. We're plugging in the same numbers the way we've always done. The only difference is right here where we need that T-score, we're going to go back to our applet and find it. So I'm going to switch to T. First thing I need to do is put in my degrees of freedom, which were, where did I not? Oh, 63, right up there. So I'm going to put in 63 as my degrees of freedom. And I want to capture a probability of how much? I guess I never said what percentage we were doing. Let's do a 95% confidence interval because that's pretty classic. A lot of research uses 95%. So I'm trying to capture within my distribution 95% in the middle. If I capture 95% in the middle, how much is in each tail? Well, the leftover is 5%. That 5% is going to be split, 0.025 here and 0.025 there. So that's what I need to put into my applet. I'm going to put in the p-value of 0.02. Wait, that's a t-score. Hang on. P-value 0.025, and I get 1.9999. The negative or the positive doesn't actually matter because I'm doing plus or minus on that anyway. So now I can put into my equation 1.999, okay? And if I calculate that out in my head, then I get both my bounds for my confidence interval. So what is different from what we've done before? Well, if you look at this equation, it's still x bar, it's still plus or minus, you've still got a score. That's the only difference. Now when you go to the applet, you're going to specially click on T, you're going to put in your degrees of freedom, and you'll get a different number than what Z would give you. But then it's still standard deviation over the square root of n. That standard deviation is S, as you can see right there, instead of sigma, because over here in this scenario, we were getting the standard deviation after we took a sample. It was random. It's not the true standard deviation.